Welcome to A-Star Science, part of our GCSE Must Know Chemistry series. Today we're going to be talking about rate of reaction, an important topic that you need to know for your either for foundation, higher, or separate chemistry papers. First, let's remind ourselves what a reaction is. A reaction is basically where you have a chemical change that creates a new substance. So, for example, if we have magnesium plus hydrochloric acid, we're going to get magnesium chloride plus hydrogen gas. Okay, we can balance that really quickly like that. I think it's now been balanced. And so we can see that magnesium has created a new substance, magnesium chloride. We also have a new substance in hydrogen being formed. So that is what we call a chemical reaction. Now, chemical reactions, normally you will see different signs. So the signs of a reaction could be, for example, a temperature change. You could see smoke or fizzing because a gas is released. You could see a color change. You may even see a flame for some of the more reactive metals. All of these are different signs of a chemical reaction taking place. And so we normally represent a chemical reaction by a chemical equation. So this, for example, the magnesium plus hydrochloric acid yielding magnesium chloride plus hydrogen would be a chemical equation. So that's some of the basics that we have in terms of what a reaction is, a chemical reaction is. We also need to understand that there are five factors that are going to affect a chemical reaction. And these are very important to know. The first one is temperature. So the higher the temperature, the higher a chemical reaction, the higher the rate of a chemical reaction, because these are the factors that affect the rate of a chemical reaction. The higher the temperature, the higher the rate. Concentration. And this is for liquids or solutions. The higher the concentration, for example, if you have a high concentration of an acid, that will increase the rate of reaction. Pressure. This is for gases. So the higher the pressure, the higher the rate of reaction when you have two gases reacting together. Surface area. So the higher the surface area to volume ratio, the higher the rate of reaction. So for example, powders are going to react faster than, for example, chunks, solid, large chunks of a reactant. And then finally, we have catalysts. So a catalyst will speed up the rate of a reaction. So these five factors, which I'll talk about in another video, affect the rate of reaction. Now, how do we determine the rate of reaction? Well, we can look at a chemical, an equation, a formula first. So the rate of reaction is determined by the amount of reactant used up or product formed all divided by the time taken. So for example, let's look at that reaction again that we talked about earlier. Magnesium plus hydrochloric acid yielding magnesium chloride plus hydrogen gas, and let's balance it. Very important to balance our equations, chemical equations. So on the left side is what we call the reactants. And on the right side is the products. So in this case, for example, we are using up magnesium. So if we added the magnesium to some hydrochloric acid, and we put the magnesium in here, maybe a chunk or a ribbon of magnesium, we would see that magnesium start to fizz and dissolve. And that would be the amount of reactant used up over time. But on the other hand, on the other side, so this is the reactant used up, we know that a gas is going to be formed, hydrogen gas. And so we could also measure that as the product form and look at that over the time taken. So either way, we could measure the rate of reaction using this particular formula. You can also look at rate of reaction from a graph. And this is what normally on an exam that they would have you do. They would have you look at a graph, and then you would be able to determine the rate of reaction. Now, I know that this is the reaction or the formation of the products. The reason why is it starts at 0. So there are no products formed. And then over time, you can see the products start to go up. I also know it's a gas because it's in centimeter cube. And so that is the way that we are going to measure the gas that's formed. So we're looking at the rate of reaction of how a product is formed over time. Now, how would we do this? Well, there are two ways. If they ask you for the mean rate of reaction at a specific point, for example, at 4 minutes, let's say you wanted to find a rate of reaction after 4 minutes, you simply will go up from 4 minutes and look at the product form. And in this case, that's 40, because we know that the rate of reaction is the amount of product formed, which is 40 centimeter cubes, over time taken, which in this case is 4 minutes. And so that would be 10 centimeter cubes per minute. That would be the rate of reaction. 10 centimeter cubes of this gas, which is hydrogen in this case, is forming every minute. And that's how you do it if they ask for the mean rate of reaction. The second method that we would use to determine rate of reaction is if they ask for the rate at a specific time. So let's say again, we were going to ask for the rate at 4 minutes. So this isn't the mean rate, it's the instantaneous rate at that specific time. Now, in this case, you're going to draw a tangent line at that particular spot. So again, I go up from 4 minutes, and then I need to draw my tangent line. See if I can do that. So a tangent line just touches the curve. I'm going to adjust that around a bit so we can make it get to just touching at 4 minutes. And that's about a good spot there. So we can see it's a tangent line. It's just touching the curve. at 4 minutes, approximately that spot there. And now using that tangent line, we can then do a triangle. I'm doing this freehand. And you're going to find the gradient, which is going to be the rise over the run. The rise over the run. In other words, the change in y over the change in x. And that would allow you to find the gradient at that particular point. So let's see how we can determine that on this graph approximately. So we can see that the rise goes from about 60 down to about 15. Okay, so that would be 60 minus 15. And the run, it's from 7 minutes. So that's from 7 minutes all the way to 0. So obviously that's 7 minus 0. Okay, and we can work that out. So that's going to be 45 centimeter cube over 7 minutes. Let's get the calculator real quick. And that's going to be 6.4 centimeter cubes per minute. 6.4 centimeter cubes per minute. And so that's how you would do the instantaneous rate at a specific time, by drawing a tangent line. Remember to look at the question. If it says do the mean rate, then you simply go up from the number, from the time, and go over to the y-axis and do the y over the x. But if they want the instantaneous rate at that specific time, then you're going to draw a tangent line, because the tangent line tells you what the slope is at that specific time where the tangent actually touches the graph.